Okay, in this video, we want to solve a couple more problems using the technique of logarithmic differentiation. And in each of these problems, we also want to use the properties of logarithms to keep the problem as simple as we can. And here for the first one, we have the natural log of e to the x divided by 1 plus e to the x. And we could rewrite this if we wanted to. We could say y will equal the natural log of e to the x minus the natural log of 1 plus e to the x. We haven't solved anything yet. We just rewrote this expression here using the properties of logarithms. Now we want to find dy dx. So for this one, and again our formula is for the natural log of u, if we want to find the derivative of this with respect to x, it's 1 over this quantity times the derivative of that quantity with respect to x. So here it would be 1 over e to the x times the derivative of e to the x, which is e to the x, minus, with this one here, it's going to be 1 over that quantity. So this is going to be in the denominator, times the derivative of this quantity, which is just going to be e to the x. So this is going to equal 1 minus e to the x divided by 1 plus e to the x. And that will equal, it looks like just e to the x in the numerator divided by 1 plus e to the x. And there's our answer. So for here we could say the derivative with respect to x of this, the natural log e to the y divided by, or e to the x divided by 1 plus e to the x, that will equal, this right here is just 1, because we have 1 plus e to the x minus e to the x just leaves us 1 up here. Okay, so this just equals 1 over 1 plus e to the x. And that's it, our problem is finished, if we don't make silly mistakes like we made over here. Alright, let's take a look at the second example. Here we have y equals and again we can use our property of logarithms. That would be the natural log of 5 times x squared plus the natural log of the sine of x minus the natural log of 3 plus x to the 4th power. Here we're multiplying. That's the same thing as adding. Here we're dividing, of course, that's the same thing as subtracting. And one other thing that we can do is, this is to the 4th power. We can take this number and multiply the log by that number and write it like this. We can do the same thing here. This is simple enough. We'll just leave it alone though. Okay, now we want to find dy dx. So that will equal 1 over this, and then we want to take the derivative of this. That's going to be 10x dx dx, which is just 1. So that takes care of that part. And the derivative of this, that's going to be plus 1 over sine of x times the derivative of that. That's the cosine of x dx dx. That's just 1. And then here we'll have minus 4 1 over this over 3 plus x times the derivative of this. But that's just going to be 1. The derivative of this is 0 plus dx dx. That's just 1. And we have a 4 here. So let's see. It looks like this will equal, this will be 2. That's going to go away. So we have 2 over x plus the cotangent of x minus 4 over x plus 3. And that's it. So the derivative of this expression here with respect to x will equal 2 over x plus the cotangent of x minus 4 times x plus 3. Now, one thing that we want to use caution on, remember this expression here. We had the natural log of 3 plus x to the 4th power. And we said that equals 4 times the natural log of 3 plus x, which is correct. But now if we had it written like this, the natural log of 3 plus x, the whole quantity raised to the 4th power, that's entirely different. This obviously does not equal that. Here we're taking the natural log of this quantity raised to the 4th power. Here we're taking the natural log of this quantity here, and the entire thing is raised to the 4th power. I'm going to take the natural log of this quantity, get an answer, and that's going to be raised then to the 4th power. That's entirely different than this. Here I'm taking the natural log of a quantity raised to the 4th power. So be careful. If we have, just to write it more cleaner, and this is an important point now, the natural log of 3 plus x, and the whole thing is raised to the 4th power, that is not the same as the natural log of 3 plus x, where the variable here is to the 4th power. So be careful. When it's like this, we can use this relationship here. But when it's like this, we have something entirely different, and we have to be careful about that. That's it for this video. We're going to have some other videos here where we take derivative of exponents, where the exponent is not a number or a constant, but the exponent itself is a variable. And that's an entirely different type of technique. So if you have a chance, turn in, watch some of those videos, and we're going to view some of these concepts then. That's it for now then.